I'm going to try and explain why it is that perhaps we don't understand as much as we think we do. I'd like to begin with 4 questions. This is not some sort of cultural thing for the time of year. That's an in-joke, by the way. These 4 questions actually are ones that people who even know quite a lot about science find quite hard. And they're questions that I've asked of science television producers, of audiences of science educators, science teachers, and also of 7-year-olds. And I find that the 7-year-olds do marginally better than the other audiences, which is somewhat surprising. So the first question, and you might want to write this down either on a bit of paper physically or a virtual piece of paper in your head, and for viewers at home you can try this as well. A little seed weighs next to nothing and a tree weighs a lot, right? I think we agree on that. Where does the tree get the stuff that makes up this chair? Right? Where does all this stuff come from? Okay, and your next question is, can you light a little torch bulb with a battery, a bulb, and 1 piece of wire? And would you be able to kind of draw, you don't have to draw the diagram, but would you be able to draw the diagram of how to do it, or would you just say that's actually not possible? The third question is, why is it hotter in summer than in winter? I think we can probably agree that it is hotter in summer than in winter, but why? And finally, would you be able to, and you can sort of scribble it if you like, scribble a plan diagram of the solar system showing the shape of the planet's orbits? Would you be able to do that? And if you can, just scribble a pattern. Okay. Now, children get their ideas not from teachers, as teachers often think, but actually from common sense, from experience of the world around them, from all the things that go on between them and their peers and their carers and their parents and all of that experience. And one of the great experts in this field, of course, was, bless him, Cardinal Wolsey. Be very careful what you get into people's heads, because it's virtually impossible to shift it afterwards. All right? I'm not quite sure how he died, actually. Was he beheaded in the end or hung? Now, those questions, which of course you've got right and you haven't been conferring and so on, and normally I would pick people out and humiliate, but maybe not in this instance. A little seed weighs a lot. Basically, all this stuff, 99% of this stuff came out of the air. Now, I guarantee that about 85% of you, or maybe it's fewer at TED, will have said it comes out of the ground. And some people, probably 2 of you, will come up and argue with me afterwards and say that actually it comes out of the ground. Now, if that was true, we'd have trucks going around the country, filling people's gardens in with soil. It would be a fantastic business. But actually, we don't do that. The mass of this comes out of the air. Now, I passed all my biology exams in Britain. I passed them really well, but I still came out of school thinking that that stuff came out of the ground. Second one, can you light a little torch bulb with a battery, a bulb, and 1 piece of wire? Yes, you can, and I'll show you in a second how to do that. Now, I have some rather bad news, which is that I had a piece of video that I was about to show you, which unfortunately the sound doesn't work in this room. So I'm going to describe to you in true Monty Python fashion what happens in the video. And in the video, a group of researchers go to MIT on graduation day. We chose MIT because obviously that's a very long way away from here and you wouldn't mind too much. But it sort of works the same way in Britain and in the west coast of the USA. And we asked them these questions, and we asked those questions of science graduates, and they couldn't answer them. And so there's a whole lot of people saying, I'd be very surprised if you told me that this came out of the air. That's very surprising to me. And those are science graduates. And we intercut it with, we are the premier science university in the world, because British like hubris. And when we gave graduate engineers that question, they said it couldn't be done. And when we gave them a battery and a piece of wire and a bulb and said, can you do it? They couldn't do it. Right? And that's no different from Imperial College in London, by the way. It's not some sort of anti-American thing going on. As if. Now, the reason this matters is we pay lots and lots of money for teaching people. We might as well get it right. And there are also some societal reasons why we might want people to understand what it is that's happening in photosynthesis. For example, one half of the carbon equation is how much we emit. And the other half of the carbon equation, as I'm very conscious as a trustee of Q, is how much things soak up. And they soak up carbon dioxide out of the atmosphere. That's what plants actually do for a living. And for any Finnish people in the audience, this is a Finnish pun, we are both literally and metaphorically skating on thin ice if we don't understand that kind of thing. Now, here's how you do the battery in the bulb. It's so easy, isn't it? Of course, you all knew that. But if you haven't played with a battery in a bulb, if you've only seen a circuit diagram, you might not be able to do that. And that's one of the problems. So why is it hotter in summer than in winter? We learn as children that you get closer to something that's hot and it burns you. It's a very powerful bit of learning, and it happens pretty early on. By extension, we think to ourselves, why it's hotter in summer than in winter must be because we're closer to the sun. And I promise you that most of you will have put that. Oh, you're all shaking your heads, but only a few of you are shaking your heads very frantically. The other ones are kind of going like this. All right. It's hotter in summer than in winter because the rays from the sun are spread out more, right? Because of the tilt of the Earth. And if you think the tilt is tilting us closer, no, it isn't. The sun is 93 million miles away, and we're tilting like this, right? That makes no odds. In fact, in the northern hemisphere, we're closer to the sun. We're further from the sun in summer, as it happens, but it makes no odds, the difference. Okay, now, the scribbled diagram of the solar system, if you believe, as most of you probably do, that it's hotter in summer than in winter because we're closer to the sun, you must have drawn an ellipse, right? That would explain it, right? Except, you're nodding. Now, in your ellipse, have you thought, well, what happens during the night between Australia and here, right? They've got summer and we've got winter. And what, does the Earth kind of rush towards the sun at night and then rush back again? It's a very strange thing going on. And we hold these two models in our head of what's right and what isn't right. And we do that as human beings in all sorts of fields. So here's Copernicus's view of what the solar system looked like as a plan. That's pretty much what you should have on your piece of paper, right? And this is NASA's view. They're stunningly similar. I know, I hope you noticed the coincidence here. What would you do if you knew that people had this misconception, right, in their heads of elliptical orbits caused by our experiences as children? What sort of diagram would you show them of the solar system to show that it's not really like that? You'd show them something like this, wouldn't you? It's a plan looking down from above. But no, look what I found in the textbooks. That's what you show people, right? These are from textbooks, from websites, educational websites, and almost anything you pick up is like that. And the reason it's like that is because it's dead boring to have a load of concentric circles, whereas that's much more exciting to look at something that angle, isn't it? Right? And by doing it at that angle, if you've got that misconception in your head, then that two-dimensional representation of a three-dimensional thing will be ellipses. So it's crap, isn't it, really, as we say. So these mental models, we look for evidence that reinforces our models. We do this, of course, with matters of race and politics and everything else, and we do it in science as well. So we just look for, and scientists do it constantly. We look for evidence that reinforces our models, and some folks are just all too able and willing to provide the evidence that reinforces the models. So being I'm in the United States, I'll have a dig at the Europeans. These are examples of what I would say is bad practice in science kind of teaching centres. These are from La Villette in France, and the Wellcome wing of the Science Museum in London. And if you look at the kind of the way these things are constructed, there's a lot of mediation by glass, and it's very blue and kind of professional in that way that Woody Allen comes up from under the sheets in that scene in Annie Hall and said, "God, that's so professional." That there's no passion in it, and it's not hands-on, right? And no pun intended. Whereas good interpretation, I'll use an example from nearby, is San Francisco Exploratorium, where all the things that the demonstrations and so on are made out of everyday objects that children can understand. It's very hands-on and they can engage with and experiment with. And I know that if the graduates at MIT and in the Imperial College in London had the battery and the wire and the bit of stuff and been able to do it, they would have learned how it actually works rather than thinking that they follow circuit diagrams and can't do it. So good interpretation is more about things that are bodged and stuffed and of my world, right? And things that where there isn't an extra barrier of a piece of glass or machined titanium, and it all looks fantastic. Okay, and the Exploratorium does that really, really well. And it's amateur, but amateur in the best sense. In other words, the root of the word being of love and passion. So children are not empty vessels, okay? So as Monty Python would have it, this is a bit Lord Privy Seal to say so, but the children are not empty vessels. They come with their own ideas and their own theories, and unless you work with those, then you won't be able to shift them, right? And I probably haven't shifted your ideas of how the world and universe operates either. But this applies equally to matters of trying to sell new technology, for example, where in Britain we're trying to do a digital switchover of the whole population into digital technology. And it's one of the difficult things is that when people have preconceptions of how it all works, it's quite difficult to shift those. So we're not empty vessels. The mental models that we have as children persist into adulthood. Poor teaching actually does more harm than good. In this country and in Britain, magnetism is understood better by children before they've been to school than afterwards. Okay? Same for gravity. Two concepts, which is quite humbling as if you're a teacher and you look before and after. That's quite worrying. They do worse in tests afterwards, after the teaching. And we collude. We design tests, or at least in Britain, so that people pass them, right? And governments do very well. They pat themselves on the back. Okay? We collude. And actually, if someone had designed a test for me when I was doing my biology exams to really see whether I'd understood more than just kind of putting starch and iodine together and seeing it go blue, and really understood that plants took their mass out of the air, then I might have done better at science. So the most important thing is to get people to articulate their models. Your homework is, how does an aircraft's wing create lift? An obvious question, and you'll have an answer now in your heads. And the second question to that then is, ensure you've explained how it is that planes can fly upside down. Aha, right. Second question is, why is the sea blue? All right, and you've all got an idea in your head of the answer. Why is it blue on cloudy days? Ah, see. I've always wanted to say that in this country. Finally, my plea to you is to allow yourselves and your children and anyone you know to kind of fiddle with stuff, because it's by fiddling with things that you complement your other learning. It's not a replacement, it's just part of learning that's important. Thank you very much. Now, yeah, go on.